So now we have a new type of number. And so let's think about numbers real quickly. All right, we got different families of numbers. All right, so when you were younger, you started learning the counting numbers, or what we call the natural numbers. The natural numbers are numbers like 1, 2, 3, okay, so on and so forth. And then when you got a little older, you learned about the whole numbers, which are just the natural numbers and the number 0. So we're going to make a little Venn diagram here, kind of. All right. So the whole numbers include 0 and all the natural numbers. Okay. And then when you got a little older, you learned about these numbers called the integers. And the integers include all of these numbers, the whole numbers, the natural numbers, and they also include numbers like negative 1, negative 2, negative 3. Okay, so integers is kind of the next level of numbers there. All right, again, integers included negative whole numbers, 0, and all the natural numbers. All right. And then, all right, you were introduced to numbers like a half and a third and 0.25 and 0.1, which is the same as 1/10. These are all numbers that can be written as fractions. All these numbers can be written as fractions. These can be written as fractions. And so that's the world of rational numbers. All right. Rational numbers include the integers, they include whole numbers, they include natural numbers, and they also include these fractions and decimals. Okay, these are decimals that end. They're repeating, so we should also put like 0.3 repeating. Any decimal that repeats can be written as a fraction. So anything that can be written as a fraction, and decimals that repeat or decimals that end can be written as a fraction. Okay, 0.19 is 1900ths. All right, so those are rational numbers. Okay, now we've introduced recently to numbers called that are irrational. These are numbers that can't be written as fractions or ratios, and those are numbers like the square root of 2, the square root of 5, pi, which is about 3.14159. And it goes on forever, and it never ends, and it never repeats. We're going to learn about a new number called e. That's kind of similar. E is, we should put an approximate there. E is approximately 2.71828. All right. So anyways, any square root that doesn't simplify, those are irrational numbers, okay? And those are separate, okay? They do not belong to the family of rationals. They're totally different, okay? They are irrational, okay? However, in fact, okay, so there's no space in between that. Now, when we put these together, these are the real numbers. Real numbers includes all of the rationals and the irrationals, all right? Those together make up the real numbers, okay? Now, we also have numbers that are imaginary numbers, okay? Imaginary numbers are like 3i, I square root of 2, negative 5i, how about 2.7i, all right? So anything that has an I attached to it is an imaginary number, all right? And then the largest and most complete, and this is the end of your number journey, by the way, when we put all of these together, we get what we call the complex number system. All right. So I know that took a few minutes there to explain, but that's really important to understand that there's these different types of numbers, all right, so we can talk about them and use them properly. So the complex numbers includes numbers that are real and imaginary. So it's the union, we say, the real numbers and the imaginary numbers. All right, and we're going to put a complex number can be written as a plus bi. Okay, where a is a real number and bi is an imaginary number. Okay, so if b is 0, we have just a real number. If a is 0, this becomes just an imaginary number. Okay, all right. So how do we work with these complex numbers? Okay, so if we have a number like, so the key here, first of all, when adding and subtracting, we want to treat them just like variables. We're going to combine like terms, and so it works pretty nice because for the most part, if you didn't know anything about complex numbers, but you just knew something about algebra, and I showed you this picture, what would you do? Well, you would probably just say maybe we can erase those parentheses because there's nothing out here to distribute, right? Watch out. If there was something out there to distribute, you would need to distribute it. But we don't need those parentheses. And which ones can we add? Well, if we thought about this just like a variable, 3 plus 4 is 7. And 2i plus I is 3i. Yes, just like a variable, there's an imaginary 1 there. Okay, now just like variables, we can't combine those. This has i's, this does not. All right, these are imaginary numbers, these are not. Don't try to put those together. It's not 10i. Okay, you can't do it. Again, just treat it like a variable. So just like variables where we combine like terms, here is the same story. All right, even though I means a little something different because I means the square root of -1. On this little situation, you can think of this different ways. We can, it is subtraction. We could do -3 minus -2. It might be safest, depending on your algebra skills, to distribute. So -1 times -2 is positive 2. -1 times -9i is positive 9i. And now we can just combine like terms. That's a good way to go. -3 plus 1 plus 2 is -1, and -4i or positive 4i plus 9i is 13i. And again, we can't combine the real part with the imaginary part. That's what we got. Okay. All right. What about multiplying? Well, multiplying, again, we're going to start by treating it just like a variable, but we have a little different situation. All right. So since I is the square root of -1. What happens when we square both sides? Well, we get I squared over here, and the square root of -1 is square root of -1 squared, that is -1. So I squared is -1. So that's the key to remember. So we're going to treat this just like a variable, but in the end, we're going to need to remember that I squared is worth -1. All right, so let's see how this works. So let's distribute. 3 times 4 is 12. 3 times 1, or 3 times I, sorry, is 3i. Now, just like with a variable, 4 times 2i, 4 times 2 is 8. And we have I, 8 times I. Okay, and 2i times I would be 2i times I is I squared. We can combine like terms there, and we get 12 plus 11i plus 2i squared. Now, if this was just a variable, we'd be done. But here I is the imaginary unit, so we remember that I squared is -1 because of what we just talked about. So we can rewrite this. This is 12 plus 11i plus 2 times -1. And so that's 12 plus 11i, and this becomes -2, and now we can combine like terms, 10 plus 11i. When we write imaginary numbers, or when we write complex numbers, that is, we're going to write our answer in the form a plus bi. The real number part and the imaginary number second. Okay, so that's going to be a standard procedure. All right, get the idea? If you want, you may pause. You might want to pause and try this one. See what you can get. All right, we should get something like this. -12 positive 18i, 8i, and negative 12i squared. Again, just treating it like a variable right now. Combine like terms. And now is where we want to swap out the I squared for a negative 1. So negative 12 plus 26i, and that's going to be minus 12. And that I squared, we're going to swap that out for a negative 1. So I squared is worth negative 1 there. And we end up with negative 12 plus 26i and plus 12. And those become 0, right? They just cancel each other out. Negative 12 plus 12. So we end up with 26i. So there's a good example. You don't always need to have a and bi. Sometimes we end up with just bi, or 26i in this case. All right. So we can get a complex number. We can get a purely imaginary number. All right. Watch what happens with this one here. Let's distribute. 3 times 3 is 9. 3 times negative 2, I that is. 3 times positive 2i. And positive 2 times negative 2 is negative 4i squared. Well, what happens in the middle there? Those are going to cancel, right? That's pretty handy. And 9 minus, now this is 4 times negative 1, right? So let's write this as 4 times negative 1, which is positive 4, which is 13. These are all equal. Good habit to put equal sign in. All right, so this one becomes a real number. No i's. All the i's drop out. And that's going to be very important to us there, okay? All right, so we'll use that a whole bunch in just a few minutes here on our next step. How about this one? Well, it seems like we can just combine these, okay? However, we need to simplify them first. This is I times the square root of 5. This square root of negative 5 is. The square root of negative 7 is I times the square root of 7. And this is all multiply. So now I times I is I squared. And square root of 5 times the square root of 7 is the square root of 35. Okay? So you got to simplify it first before you try to use that before you use the radical product rule. And now, what is I squared worth? Well, it's negative 1. And so we get negative the square root of 35, or negative 1 times the square root of 35. Okay? All right, so that's how we multiply. Just do the multiplying, treating it like a variable, and then in the end, swap out the I squared for negative 1.